Good afternoon. This is Saravana Gokul from SA Engineering College. Now we are going with a gate session, question and answer. Let us go with the topic of minimum spanning tree from the data structure topic. Okay. So this is the introduction about a minimum spanning tree. You see, before entering into the topic, first we discuss about the definition of the minimum spanning tree. Okay, so we have two concepts, a tree and a graph. Okay, in this tree and graph, from the tree we know that there will be a left child and right child with a root node. Okay, this is called a tree. When we go with the graph concept, graph also like a tree, but this graph has a cycle formations. In tree we do not have any cycle formation. This is the main difference between tree and graph, so that we are called, this is one of the minimum spanning tree. This is the minimum spanning tree. The main definition of the minimum spanning tree is one of the subset of the graph. Okay, for example, let me draw a simple diagram. Okay, this is the minimum spanning tree. In this graph, I am having A is one of the vertex. Okay, B is the another vertex. Okay, and C is the third vertex. And these vertex connected with the edges. This line is nothing but edges. Okay, and I am calling this is the graph. Okay, when we call it a tree in the sense of, this is the one of the root node maybe, and this B is nothing but a left child and C is nothing but a right child. We couldn't draw any connectivity between B and C. Okay, if we drawn this B and C in the sense of, this is called a graph. Okay, we should not draw for tree. This is called a tree and this is called graph. This is the main difference between graph and tree. Okay, so from the tree concept we are saying a graph concept, so the name is called as the minimum spanning tree. The only difference, in graph we make a cycle formation. Okay, so it is called as a graph. Okay, so this is the introductions. Okay, let me move to the next slide. This is the best example for our graph. Okay, so this is vertex A and vertex B, vertex C, vertex D. 4 vertex I am having. Out of these 4 vertex, these are called as edges. We can call it as edges. Okay, first edges, second and third, fourth and fifth. Out of this graph, I want to make a minimum spanning tree of all possible ways. Okay, these are all the possible ways. This is the first possible ways. From A to B I am traversing, B to D I am traversing, D to C. This is first formation of minimum spanning tree, and this is the second formation of minimum spanning tree, and this is a third possible way, and this is the fourth possible way. So out of this graph I am having 4 possible ways of formation of minimum spanning tree. Okay, let me move to the next slide. So this is rules for creating a minimum spanning tree or calculating a minimum spanning tree. Okay, this is the first rule. First rule, minimum spanning tree should contains all vertices of a graph. Okay, last slide I shown, right, a graph with all slides connected. So this is the first rule, minimum spanning tree should contains. It means that minimum spanning tree should traverse to all the vertex. For example, A, B, C. I should traverse from A to B also. I should traverse from A to C. Okay, now I have traversed all the nodes, but I didn't form any cycle. So this is the first rule. Minimum spanning tree should contains all vertices of a graph. Even you can replace the word contain, even you can say it's a traverse. Okay, minimum spanning tree should traverse all the vertices of a graph. This is the first rule we need to apply. And second rule we need to apply, if graph has n vertex, then spanning tree must have n minus 1 edges. For example, this is the A, okay, next I am B, next this is C. So it means that 3 vertex are there. So n equal to 3. Okay, now I am drawing edges A to B, A to C, that's all. Okay, so n minus 1 equal to edges. So to calculate vertex we need to count A, B, C. Likewise, to calculate edges we need to apply the formula as n minus 1. Okay, and this is the third rule, there should not be any cycle formation for minimum spanning tree. Okay, these are the 3 rules we need to follow. Let me move with the next slide. So one of the best example for minimum spanning tree is a Kruskal algorithm, and even we can call Prim's algorithm. Here the Kruskal algorithm is the best example for minimum spanning tree. Okay, and this is the introduction about minimum spanning tree. Let me repeat the concept again. So we have 2 concepts, tree and graph. Okay, in tree left child and right child will be there and root node will be there. This is called tree. In graph we have the same nodes or vertex, okay, A, B, C likewise, but in graph we create a cycle formation. In tree we couldn't create a cycle formation. This is the main difference between tree and graph. Okay, and we have some 3 rules to be followed, so I have shown that. Now let us go with the gate questions. I have 3 questions here. The question number is a 49. Question number is a 49. Okay, and year, this is the question number, and the year is CS 2020. This is one of the questions. Okay, let us check. Okay, consider a graph G equal to V comma E, where V in the sense of vertex, V equal to V1 comma V2 up to Vn. Here they given n as the 100, so no need any confusions. Okay, we can go very directly. And E equal to Vi comma Vj. E means edges. Okay, I comma j. Okay, and weight of the edge Vi comma Vj is absolute of I minus j. Okay, the weight of minimum spanning tree of G is what? Okay, already we know the formula. I shown in the next previous slide that n is nothing but how many vertex available. Here how many vertex available? 100 vertex available, since they have given in the questions. Okay, now we need to calculate the G. Okay, here we need to calculate the edges equal to n minus 1. So very easily we can calculate as 100 minus 1 equal to 99, where G equal to 99. I mean that out of 100 vertex with the minimum cost 1 for all the vertex, we can go with G equal to 99. So the answer is nothing but 99, the first answer. So this is a simple solution for this first questions. Let me go with next questions. Okay, this is the next questions. Let G be a connected undirected graph of 100 vertex and 300 edges. The weight of the minimum spanning tree of G is 500. Okay, already they given. C given G equal to 500 already given. Okay, let make a note. Okay, and when the weight of the each edge of the G is increased by 5, all these vertex increased by 5. Okay, 5. Okay, next the weight of the minimum spanning tree becomes, so we need to calculate. Okay, so already we know that here they given n as the 100. Already we know that n minus 1 equal to 99. Okay, here 100, n is 100 minus 1 equal to 99. So each vertex increased by 5 in the sense of 99 into 5 equal to 495. Okay, so this 500 is already given. Okay, we need to calculate that 495 plus 500 equal to 995. So this is the weight of the minimum standing tree becomes finally. So here answer is B. This question raised as question number 40 in the GATE CS 2015. Okay, this is the second questions. Next we go with third questions. Okay, let G be a connected undirected graph with n vertex. N vertex, they didn't give any n value. Okay, n vertex and m edges. And m edges, which of the following statement is true? They are asking which statement is true regarding the minimum number of edges required to create a cycle in G. Okay, now there are four topic. Okay, four answer. The minimum number of edges required to create a cycle is n. Okay, and the minimum number of edges required to create a cycle is n minus 1. Okay, and the minimum number of edges required to create a cycle is m minus n plus 1. So it means that this question, this answer is not applicable, and this answer also not applicable, and the minimum number of edges required to create a cycle is m minus n plus 2. This answer is also not applicable. Only the applicable answer is the minimum number of edges required to create a cycle is n minus 1. Okay, if we need to create a cycle, so we need definitely n minus 1 as the formula. So this is the correct answer. So this question number is 41 in CS 2024. They asked these questions. Okay, so let me conclude the topic. Okay, so this is a minimum spanning tree concept. In this minimum spanning tree concept, we need to calculate the minimum cost to traverse from one location to another locations. So there will be a source and destinations. I need to traverse from source to destination. Here I need to check out the minimum cost to traverse. Okay, let me solve or let me explain a small example for this minimum spanning tree, and let me close it. So let me take this example. Okay, out of this let me find the minimum spanning tree. Okay, so from A to this is a source. Okay, from the source I am traversing. From A to D I can traverse, from A to B I can traverse. The cost I am checking is both are same. So let me go with A to D. Okay, with the weight of 5. Okay, next I'm standing here now D. From D to B I can traverse, D to C I can traverse. When I am traversing from D to B, this cost 2 and D to C cost 4. So let me choose D to B. 2. Okay, I'm standing now at B. If I traverse from B to A, it would create cycle, so I couldn't travel from B to A, so I'm traversing from B to C, so with the minimum cost 1. So okay, so I couldn't traverse from C to D. If I traverse, then there would be a cycle. Okay, so let me calculate the weight of these things. 5 plus 2 plus 1 equal to 8. So total cost of this traverse is 8. Okay, let me calculate here. Okay, 5 plus 2, 7 plus 4, 11 for this possibilities. 5, 10, 14 for this second possibilities. 9 plus 1, 10. It's a third possibilities. Here 7, 8. Fourth possibilities. Among this is one of the minimum cost spanning tree. So we would prefer only this path to be traversed, since it's showing 8 as the minimum cost. So this is the introduction and this is the explanation of minimum spanning tree. From the topic of minimum spanning tree, we go with the algorithm called Kruskal and the Prince algorithm. Let me explain that Kruskal and Prim's algorithm with some gate questions from the next session or next video part. So let me conclude. Thank you for this wonderful opportunity given by SA Engineering College for this gate sessions. Let me meet you in the next video. Definitely. Thank you for you.